Hello and welcome to our today's training in the series RFEM 6 for students. Today we will have the introduction into the concrete design. Before we start, let me introduce myself to you. My name is Juliane Stoppagter. I'm working in the Dlubal team for now around about 4 years, and I'm on the one hand working for customer support, so customers can call us or email us with questions regarding our program or their models, and we support them. Then we try to find solutions for them, and also we give trainings. And on the other hand, I'm working for the developer teams. I'm supporting the developers of the add-ons reinforced concrete design and geotechnical analysis. Yeah, and with the development team, we always work on improvements for the program. Yes, and I today will hold this training for you. I will give the presentation to you. And we are not alone. We have my colleague Richard Hase with us, who's supporting us with the questions in the chat. You can ask questions, and how this can be done I will show you with the next slide. And I will also close my camera so that you can see the PowerPoint full screen. So this is the control panel that you can see, and there's this setting here, this option here to go to audio settings if you have problems with the with the headphones or something. You can adjust your audio settings in here, and with this button here with the little question mark, you can open this window where you can enter your questions. These questions will go to Richard, to my colleague, and then he can reply to you. And don't worry, if there are questions open at the end of this training, we will reply them with emails. You will get an email afterwards. No question will stay open. We will reply to all of them. And this training is going to be recorded. You will also receive this record after the training. You will get an email with the link for downloading it. And yeah, there you can watch this video again, and you can follow the training again if you want to repeat some stuff. Yes. Okay, then I think that's enough now for preparation. We can go to content. This is the plan for our training today. We will at the beginning have a look at an introductory example, a concrete beam. And we will model the beam, we will put the loads on it, and then we also will have a look at the design properties that we need for concrete design, and we will do the finite element analysis for our system and also the concrete design in the same time. And afterwards we will have a look at the results of the static analysis, the finite element analysis, and also the concrete design. After this example, we will also have a look at a concrete slab, and we will do the design for it too. Yes, that will be it for today. Yes, and now we will go to the program. Okay, we have here our RFEM 6, and we will open a new model, which we can do here. We have here this button to open the next model, and the first thing we do is we come to the base data where we can give it a name, and this will be our concrete beam. This is the name, and all the default setting in this register we will keep. Now we go to the next register, which is about the add-ons. RFEM 6 is a finite element program. With that you can do the finite element analysis for your model, and you will calculate inner forces, deformations, stresses, strains. If you want to do some additional analysis, you can add here the add-ons, and we today want to do the concrete design, therefore we have to switch it on in here. With this action, with switching it on, the main program will be enlarged. It will get the options for giving the input. It will get the analysis and the results for the add-on you activate in here. So it will be added directly into the main program. And what we need to do for concrete design 2 is we have to go to the standards, as we have to tell the program according to which standard the design shall be done. So we have here now the Eurocode and the National Annex 10. We keep these settings and we agree. And now our model is prepared. The file for it is prepared. It is empty. I will open this here more so that we can see it more big. I want to show you the files in RFEM 6. They always provide some default options. The program keeps in mind which materials, which sections you did use the last time. It can help for a new project, but for us now we want to start from scratch. Therefore I delete all these objects so that we can start in a fresh file. So what we do now is we go to the materials, and here we create a new material, and we therefore provide here the library. We can go into here and we want to select our concrete, and it is important that you take care of that the standard according to which you want to do the design, that you should select a material according to that standard. So we have C3037. I accept that and I go on apply. Then I can see also here on the navigator that it is added. And I want to have another material. I also need the reinforcing steel, and I want to show you another way of giving the input. You also, if you do know the name, you can also directly enter here the name of the material and then take it from here. And I want to take this one, and it does the same actually. You give the name and then it takes the input from the library, but it can be faster if you know the names. Okay, now we have the materials assigned, and you can see that it is written in blue letters here. This means that these objects are prepared in that model, but they are not in use. We will later see that if there are objects used in the model, then the letters will be black. So it's a good way. It makes it easier to control, to see if you missed the assignment somewhere. Okay, then we can go to the sections. We want to create the section for our beam, and this is the dialog for it. We have as equal to the materials, we also have for sections a library. You can enter here, and here you can see a lot of different sections we provide in RFEM. But I want to cancel this. I want to show you here on the right side, we also have a list of common cross sections that are used. The program automatically adds here the first material of the list. It fits for us. We want to have a section with a concrete material, and for this material it proposes these cross sections, and we want to use the rectangular, so it's fine for us. We can go to the next register where we can enter the geometry for our section, and we will have 300 in this direction and 458. And I can say OK. And then I have my cross section prepared, and you can see it uses the concrete, so this became black here. And now we can directly model our beam. We have therefore here this menu, this button, to create a new single member. I click on this and I create a member, and I can also check here the section. Yes, this is the section I did define. And now I can start, and I have the grid points here. So I want to start in 0, and our member shall be 8 meters long. And with the grid here, it's quite easy to find the 8 meters. I click on the grid point and my beam is defined. Now I want to add a node in here, in between, in the member, and we have a special type of node we can find. For example, if we do a double click on the member, we come back to the member menu, and here we can use the option to define a node on member, or more than one, but we only need one. And as I activate this option here, this register comes. You can see it's not here, now it comes, and I can enter the position of the node, but I want to not give the data in percent, so I click here and now I can give it in meters, and I want it to be placed 6 meters from start, and I go on OK, and now you can see that here I have an additional node. Okay, now we have the beam. What we need now and what we do now is we define the support. Therefore, I select the member start. I do click double on the node, and I'm in the nodes register, and here I have the option to assign a support. And again, the special register for that option opens up, and here I can create a new nodal support for this node. And I want to have a fully fixed support, and I go on OK, and then this node is supported. We can see here the green thing, and I want to have another support here at this inner node, and I go here on support again and create new support, and I want to have now a sliding support. I use that one, which is sliding in X direction, and I also want this to be fixed, the rotation about X axis. Okay, I go on OK. With this node on member, we have the option that there is a node at that member, but this node doesn't divide this member into 2 parts. This is quite helpful if you want to do the concrete design for it, and the reinforcement will work as for one member. Okay, now we have our beam ready. What we now do need is the loads. So therefore we can go now here a bit more down in the menu, and I do a right click on load cases and combinations, and we see the dialog here, and we have here the load cases. What the program provides as standard is a self-weight load case. We have here the self-weight active, and now we add further load case, and I want to have a dead load case. It's also from action category permanent. I go on apply and I create a new load case, and this will be a live load, and I select this action category. It is important to select the proper action category, as the action category decides how this load case is considered in the design situation in the load combinations. So this is my live load, and I say live load 1. You will see later why, and I copy this load case and I create here live load 2. Okay, so then I go on apply again, then it is in the model. Now we can go to the next registers and have a look at them. Here we see a list of all the action categories we have in the model, an overview. Then we can go to the design situations, and these are the design situations that are used for the different design checks. And you can always, for all of these, click here on this info button, and there you get the info about the combination rule, which is used for creating the load combinations. So it can be followed. And we have here the frequent design situation. You can see that all of them are now used in the concrete design. And I can also here deactivate it and say, this design situation I don't want to have considered in the concrete design, as I don't need it right now. Then we can go to the next, and here we see how all the action categories we have in our model are combined. And then we can have a look at the load combinations. This is the list of all load combinations that are automatically generated for us, as we have here the combination wizard assigned. If you switch it off, you can manually define combinations for this design situation. If you have it active, as we saw, the load combinations are generated. I go on OK, and all my load combinations, they are prepared. Now we have to fill these load cases that we have prepared with loads. Therefore, we look at here, we have now for every load case here a different folder, and we now go to the dead load. And I want to define the member load, and I use this button here, new member load. I go on here and I start with the dead load, and I can select the member, and I want to have 1.5 kilonewton per meter assigned, and in Z direction this is fine. All these settings can be kept. And now we have this button here, apply and next. I want to use it because I can then stay in that dialog, and we can have a look here at the background. The load was defined, and now I can go to the next load case and define my next load. And it is still member number 1 for which I want to define the load. And now I want to use another load distribution. I'm using trapezoidal, and I use 20 kilonewton per meter at the end and at the start. And the load shall reach from the beginning up to 6 meters. And again, I go on apply and next. Now I can see that this load case, it's the live load for the first span, is defined. And now I can go to the second, again member 1, and now I change it here. It shall start from 6 meters and reach out till the end of the beam. And I can now go on OK, as it is fine for me to leave that dialog also. So now we can check them. We can go backwards. We have this live load, we have this live load, we have the dead load, and we have the self-weight load case. It was the one with the self-weight active in the dialog. And we can also see that if we go here on the navigator for display, and here in the loads, in this navigator you can control a lot of settings for the display in this main working window. And we can here activate the self-weight. And this is the self-weight that is automatically calculated for us with the cross-section and the material's weight. And here we can see what the program calculated. Then we can also see here our load combinations. The program shows us the factorized loads, and we can have an overview about what is assigned in this load combination. Okay. Now we are at a point in the modeling process where we could start the finite element analysis. We have a system, a structure that has boundary conditions for geometry and for loads, and the finite element analysis could be started. But as we want to do the concrete design as well, we will now have a look at the design properties for concrete design. Therefore, we go here to the member, and we can see here the design properties. This appears here as the program has the concrete design active, and as soon as an object is of concrete, then these properties are available. And we could also switch them off. Then we would see the pure dialog for the member, how it would look for the member. And if we have it not active, this member would not be part of the concrete design, as it has no concrete design properties. But we want it to be designed, that's why we switch it on. And then we can go through the concrete design registers. So the first option is to define an effective length. This effective length is used for the stability design with the equivalent member method. And as we now have the beam which has no stability problem, we don't need to use the equivalent member method, and therefore we don't assign the effective length here. We can go to concrete cover. This we need. We can give the concrete durability. We have a default value here, and we can, with this button, go on edit, and we can have a look at it. And here you have this helpful graphic, and you could also change it if it is necessary, or add further exposure classes, and also set additional options if you need. But we will keep the standard settings, and we will go on. If we have the concrete durability defined, then the program can automatically calculate us the concrete cover according to the standard that we have selected for the design. But it is also possible to give a user-defined concrete cover, and it is also possible to define it different for the section sides. This can be needed if one part of a column, for example, is at the outside of the building and one part is at the inside, or something like this. But we keep the default setting. Then we can come to the reinforcement. The first register is for the shear reinforcement, and for both the reinforcement registers we have here at the beginning the type of reinforcement that we can select. And we have the stirrup type, and we have now a 2-legged stirrup, but we also provide 3-legged stirrups, but we stay with 2-legged. And here's the material. The material is automatically the first reinforcement material you have in your material list is selected here. It is assigned here, but you can also change it if you have further in your model. Then you can define the stirrup parameters, and we want to use 8 millimeters stirrups, and you can also define the distance for the stirrups, and if you need, you can also define further fields of stirrups. You can have different stirrup reinforcement area in different parts of the member, but we keep now the setting that we have one field along the whole member. Okay, that's it for now. We keep it like this for the shear reinforcement. We can come to the longitudinal reinforcement. Here's analogous. You also can select the rebar type in here, and we have as default symmetrical here, but we want to use an unsymmetrical reinforcement. And as we know, we have in our beam mainly at the bottom side tension. We want to keep the stronger reinforcement for the bottom side, but for the top side we want to reduce it. We go on 14 millimeters. Yes, and again, it also finds the reinforcement material, and we can also see here the reinforcement area as information. Then you can check whether it fits to the values you would like to have. And the same was available here also. You see also the area for the stirrups. Yeah, this is the reinforcement we want to use now in our example. I go and apply once in a while, and then we can go to the next register. Here we have configurations assigned, and we can go into the ultimate configuration. Here you have selected all the settings that we provide according the design, according to the selected standard. There are several options provided also in the standard and also in our program then, and you can go through these points and select the settings that fit for you. You can, for example, unselect the detailing rules for the members if you wish to have a design that is led by the ultimate state, but you also can activate it, have it activated as it is here, if you wish to consider the minimum requirements of the standard and so on. We have here also the option to do the design for the shear joint, which we don't need here. For the rest, we keep the default settings. And we have it similar for the serviceability limit state. Here also you can select which checks you want to do. We have the limitation of shear stress active, but the concrete stress not yet active. You can activate it, and you have the minimum reinforcement area for crack limitation, and we can also activate the limitation of deflection. I will for now not consider this. You can select here what you want to have in your design according to that standard. Then we can go here to the design supports. Design supports you also need for the program. It is relevant for design checks. The program needs to know at which node the current member has a support and at which node it doesn't has. Therefore, we go here to the member start and we define a new design support. It shall be considered in the Z direction, and it has that width, and the support depth it takes from the member width. And we have a monolithic connection, and there's no inner support at the member start. So we have this design support, and we create another one, which is an inner support. And we go on OK. And we have the first support here, which was the not inner support. And at the end of the member, we don't have a support. We have a design support at the internal node, and there we can assign now our second member support. We can see here now the program knows our member is supported here and here for the design checks. We go on OK, and then we have it in our model. Okay, I think then we are ready. Yes, we are ready. We can start our calculation, and I want to start it from here. We have here the table, and we have all these objects that we saw here, all the objects that we did define. We also have in the table, and we can have the view of the table too. Sometimes it's useful to work with the table too. And here we can find the concrete design as well. Here you see the design situations that are now considered in the design, and here also you can switch them off if you say you don't want them now, and you can select the objects that shall be designed, and from here you can start the concrete design. I will click on it, and now the program starts with the mesh. And afterwards, the finite element analysis is started. The inner forces, the deformations, stresses, and strains are calculated. And then as we have them, the concrete design is done with these inner forces. And now we see the result. Yes, what we do see now at first is here the overview for the concrete design. Maybe I start here. We have here the navigator for results, and we are now in the concrete design. But it's always possible to go back on the static analysis. Here you can find the results of the finite element analysis. And you can check, for example, the deformations, whether they are plausible. Let's have a look at them. We can go on the wireframe model, and I want to switch off the reinforcement. I don't want to see it now, as I want to focus on our results. Now we can see more clear the deformation, and we can also select here that we want to have the section colored, but we can also go back to lines. So as we see, we can go to static analysis, and these results from the static analysis, the inner forces, they are used for the design. And what we have here is the overview. It looks relatively red because you are warned in that overview according the positions where you have to work on. But you can also go here on design ratios on members, and I will show it. It is a lot, relatively a lot, and you can also deselect options here. We have now here the ultimate limit state results, the serviceability limit state results, and also detailing checks. And with these buttons, we can select what shall be shown in the table. And I don't want to see now the constructive rules, the detailing, and I don't for now want to see the serviceability limit state. I want to work on the ultimate limit state now. And we can see that we have here a value reached. The safety is not provided in that ultimate limit state. And this is our section resistance check. And I guess it is caused by this support, by the moment we have here from support. And we can have a look. Here we can see the design check. This is only the UL 100, and we can see that we here don't fulfill the check, but we can also have a look on the reinforcement. So I switch off the design check and go to the reinforcement, and here we can see the required longitudinal reinforcement at the top and at the bottom. And we can also have a look at the provided reinforcement at the top and at the bottom. And there we can see that our problem is the top side. So it's really the support, the moment from the support. We have tension on the top side, and for this tension our reinforcement is not enough. You can check it like this, if you look like this, but you can also directly go to the result not covered reinforcement. Therefore I switch off the required and the provided, and we just open this one. And there we can see that in this range the reinforcement is not enough. And now we will modify our reinforcement in order to fulfill this check. So therefore we can go here directly. I did do a double click on the member, and I get back to the members dialog, and I saw that I need 4.8 centimeter square. So we have 4.6. So I want to use, I copy this reinforcement item, but I only need additional reinforcement at the top side. So I set this value at the bottom side on 0. And this is not enough. Therefore I go on 4. And I have it now in my member. And what I see is that now this item is placed along the whole length. This I don't want, I don't need. We saw it's a very limited zone. So I can here define the span location. and I want to do it absolute, and I want to start from 0. This is good, but I want to go only to 2.5 meter. And there we can see now here it is only in here. This is what I want. And I can see that is in the same layer of reinforcement, and I want to use an offset. This I can do here too. I go on offset from stirrup, and I go from top side 30, and now I see it's better. And yeah, this reinforcement I want to use now. Sorry, I want to go back to dialog. One thing I wanted to show. If we are in the reinforcement register, we can also click on this here. Here we can see the reinforcement layout. And yeah, this is a good overview about all the reinforcement positions you have in your member. And this one you can also print. And you can also use this as a template and do multi-print for this setting. Then you can print a lot of members with one click with the same layout style. Yeah, okay, but this is enough for now. We go on OK, and we do start our design again. As we saw, static analysis results were not deleted. They were still valid. Only the design is redone. And we are now in the not covered reinforcement. We are still there, and we can see now that these values are 0 now. So on the top side and also on the bottom side, there is no not covered reinforcement, which is good for us. We can also go here on ratios on members, and we see the ultimate limit state is fulfilled now. I want to have a look also shortly on the shear check. The shear resistance is checked in this second check in the UL 200, and we can have a look on it here. Then we have it along the beam, and we can see that it is fulfilled quite well. We can also have a look here. This is the ratio for the shear force with the shear resistance without reinforcement, and we can see it would be fulfilled here. And then we have also this check and this check here, and there we see finally the total check is fulfilled for shear resistance. What I want to show now is that you always have the option to see more details of the design check. You can do a double click on the design check, and then you can see what is done in that check. We don't provide a black box. We fully document how the design check is done. So here now we are in the design check details. For that check we had a click on. So we are in the 200 for member 1 at location 0, and you also can switch through it to further X locations. And here on the right side you can see all the formulas that are calculated now within the design. And you can switch off the values, then you have an overview about the formulas, and you have here also the reference to the standard. So you can quite detailed follow the design check and also see it with the values you have. And it is quite useful to check if there's a problem in the design check. If it is not fulfilled, you can see which value is leading, where should you work on. Yeah, so these are our design check details. You can also use this button here. It's helpful too. There you can see the stress state of the current member's location. And we can see now here at this location we have tension on the top side and compression on the bottom side. You can also check dimensions here, different settings, and you also can print this. And then you also can come here to that result diagram. Here with this design check details you are at one location in the member. Now if you open this one, you can see the current design check along the whole member. And you can see how it behaves through the member, how it develops. Yeah. So, and this one you could also print, and you can here now add something, some information you want to know. You can check and you can print it from here to the printout report. You can directly print it, whatever you need. Yes, this is it for here. Let me check whether there's something else I would like to show. No, that's it. We have here also the interaction diagram. This as a very short note. You can also check the state your cross section is in here, yeah, in detail. Yes, but for now it's enough for the member. I think we are ready. We finished our introductory model. Then we can come to our slab, and for this I want to go back to the slide. I have a short overview about the slab we want to work with. It's a reinforced concrete slab, which is 24 centimeters thick and uses a C30-37, and it is supported by walls and columns. And we also have here these L beams. And we have loads in the model. We have self-weight and live load. And now we open the model for us. We have it here. For this model, I have the structure prepared in order to save some time and spend the time with the concrete design. So as we can see here, we have the concrete slab. We have our materials in the list, and we have sections, and I want to go to the section. This is the section for these L beams, and we can have a double click here. For this type of beams, we have in RFEM a special member type, which is called rib. If we go into here, we can see that we have now the member type rib used. Before we had the beam, as it was a single beam, but here it is a rib. This means we have the working together, let's say, of that member and the slab, which is within the effective width of the member. And here we have the special register for the rib, and here you can do some further settings. You can select whether your rib is placed at bottom side of the surface or top or at the center. You can use the auto detection. There the program finds for you the surfaces that are placed at the rib. It can from time to time be needed to use the manual definition. Then you can unselect the auto detection and so on. Here you can do settings for the flange dimensions. And here you have the overview. Yeah, like this. It has here the design properties provided as it is from concrete material, but I don't want to do the design for the rib right now. We want to focus on the slab. So we have the section here and the rib members here. What we do have in that model too is the thickness. The thickness is analogously to the section for members. We have the thickness for surfaces that we can define here. We can go into the dialog. Yeah, and here we can see the thickness and the material assigned, and it is assigned to the surface number 1. And if we now, we can also see our surface here. If we go on that surface, we can see the surfaces dialog. And Yeah, here we have the thickness assigned, and we can also see the material, and therefore we again have design properties active here. And yeah, as we are already here, we can go through it. I can show this would be the dialog without design properties, and these are the additional concrete design settings. And we have here the concrete durability again that can be defined, and the automatic calculation of the concrete cover, and it can be user defined here too. Okay, then we can go to concrete design properties. Here we can select which direction of the local axis of the surface shall be the first reinforcement direction. And then we can come to the reinforcement. Here we can define the surface reinforcement, and I can go on this button here and define a new surface reinforcement. We have here the type on surface, which means that this reinforcement is placed along on the whole surface area. And we want to use the 10 diameter as diameter and the rebar spacing of 15 centimeter, and we want the same in the transverse direction. And here you have the surface reinforcement area values. This reinforcement is placed at top side and bottom side. Yeah, and we can go on OK. And then we have it assigned. Okay, and we have here design configurations too. Yeah, and here you can go through again and select the options you need in your model. And here we have a deflection register that we don't use right now. Yeah. Then our surface is prepared also with the design properties. Now I want to show you something special we have. We saw in our graphic that this slab is supported by walls and columns. It is placed on them. But as we are interested in the slab only, we don't want to analyze these walls and these columns. But we want to consider the stiffness, and what we have in this case and what simplifies the model is we have special supports. And we have here line support, for example. I can do a double click on the line support, then I get into it, and this line support uses the option stiffness via fictitious wall, and this has this special register here. And here we can see that we can set the parameters of the wall, and then the program automatically calculates for you the support springs, the equivalent support springs due to this wall. So you have the stiffness considered, but there's no further analysis along in all finite elements of the wall, because we don't need it in this example. So we have the stiffness is assigned, and the wall with its stiffness is considered as support. We have the same for nodal supports, not the same, but the equivalent thing. And these supports you can also find in the navigator. We have before looked at the line support. The line support are here in types for lines. Here is the line support that is in use in this model. And we also have here types for nodes, and we can see how the nodal supports that are in use. And we can also now click from here. We could have gone to them in the model via clicking, but we can also use here the types for nodes. And here we see stiffness via fictitious column, and it's the equivalent thing. Yeah, you can give here now the data about the column, the material, the dimensions, the hinges, and then the equivalent support springs are calculated and put in here. Yes, and we can have them active, so we can see it a bit better that we have it considered, the stiffness. We can activate here the columns and also for the surfaces. No, not for the surfaces, for the types, for the lines. We have here the walls. And now we can see them. Yeah. So this is how our slab is supported. Now we can check the loads. So we have supports, we have the geometry, we can check the loads. We have here self-weight and dead load in that model. And here we can look at them. If we say show loads, we can see the self-weight that is considered, the live load, and we can see that we have load combinations in that model too. Okay, yeah, that's it then. We can start now the analysis, and we do this again here with the table. In this model, I wanted to show you that you can go here on concrete design on the settings, and I did switch off the serviceability, and I also switch off the detailing. So now I do only the ultimate limit state design, and I wanted to show these options to you. Here you can set which design options shall be done, and we provide also fatigue design, fire resistance design, and seismic design. Okay, we keep it like this, and we start the design. The mesh is done first, and now the load combinations are calculated, and when the inner forces are solved, then the concrete design is done and it is finished. Okay, again I want to have a look with you at the static analysis and shortly have a look on the displacements, as it is a very good option to control the plausibility. So we are now here in the static analysis, and we can see that the displacement look plausible for us. All the supports are considered. The loads seem plausible. The deformations fit to the loads from plausibility here. Then we can go back to the concrete design now. So I want to switch off this for now and go in this view. Now we see it from the top, and we again have this overview as a first result, and we see again some red cases. Now we will go on ratios, design ratios on surfaces. And what we see now is, if we look here, we have the safety not fulfilled for the longitudinal reinforcement on the top side. So we can also go here. It's the ultimate limit state, and we see now the top side in direction 1 and here in direction 2. And what we see is we have again at the supports a problem, so that's why it is on the top side. At the supports we have the tension on the top side, and here our reinforcement is not enough. At the bottom side we have the maximum values in the fields in the spans, and it is we have the maximum here, but it is fulfilled. We see that there's no higher value than 1. So now we have to work on these points, and this we can do. We put some additional reinforcement here. Therefore I go to the navigator for data, and here we have the I want to collapse them. We have also this place where we can give a setting for the concrete design. In the navigator for display, the concrete design is placed here and here. Here we were with the global settings, and the configurations are placed here. And here we have types for concrete design, some settings that are collected here. For example, concrete durability you can open from here. And here also our surface reinforcement. And I want now a new surface reinforcement to be defined. And it is of another location type. It's a free rectangular. And it has these diameters. It shall be 16 millimeter and with the distance of 15 centimeter. This is fine. I can see my values here. And now this reinforcement only I do need at the top side. Therefore I do uncheck the bottom side. And here for this reinforcement type we have to give the direction and location. I want to use this setting. I want to define the center and the dimensions, and it shall be 3 meters in A direction and 4 meters in this direction. And now I select my first center. Therefore I switch off the results. It's more easy to see. And I use this one. And I say okay. Yes, the results can be deleted. It's clear that concrete design has to be calculated new. So now we can see here our additional reinforcement, and I can work with it graphically too. I can select it, and if I press on Control, I can see this little plus, and then I can create a copy with drag and drop. And I want to do this. I want to have these reinforcements also placed here. And I want another one here. I did move the node too, like this. And I want another one here. And I want all these reinforcements to be placed here too. Oh, I didn't copy it. I press Ctrl and Z, then I can undo this. Now I press Ctrl and I can have a copy. It didn't work. Okay. I don't know why I am doing it like this now. I can also do a right click, say manipulation and copy, and create a copy, and I define the distance with this setting. Like this I can copy it too. Okay, now I have additional reinforcement at all the places where I wish it to be placed, and I can restart the calculation process. Okay, and now I can, I don't want to see the reinforcement right now, so that I can focus on my graphical results. And now if we go on ratios on surfaces, we can see that these ultimate limit state longitudinal reinforcement checks are fulfilled. And we have the same as options as for the beams. For the members we can also check here the required reinforcement. That was the required value, and we can see our provided value. Also we can see here that we have now additional reinforcements here. It's considered in the provided reinforcement, and we can check the not covered, and there we can see that there's no problem with not covered reinforcement at top side and also not at the bottom side, which is fine. What we have here is a shear problem, but this can be a punching issue, and for this location it needs to be checked more in detail, but it could be required that we do the punching design. But this for today will not be part of the training. This will come in the next step. Okay, so that shall be it for today. Maybe I can show you one more short thing. This is again a result, we can see the longitudinal reinforcement that is required for that surface. And as we want to print our results also for documentation, we provide here options to modify the display at the bottom part of the navigator for results, and there you can select ISO lines for the surface results, which is quite helpful, and you can additionally activate the values on surfaces, and with these values and with the ISO lines it's more easy to print. I wanted to show that. Okay, then we are at the end with the topics I wanted to show within this training. I hope you got some insight into the options in our program, and there's a lot of further options provided you can get to know. But this is it for now. We will go back to the slide. Yes. On this slide I prepared some links for you. You will also receive that slide after the training, and this is a summary of some introductional examples you can find on our website too. And then I would like to recommend this web page to you. We have a career page you can find on our website. We offer a lot of different positions in our company. We always search for students who would like to be part of our team, and we offer positions as a student or as a graduated student, and you can work in different fields for Dlubal, and I would like to recommend to you to have a look at this website. Okay, then that's it for me for today for this training. I hope you can take something from this training, and I wish you much joy with our program and also with the next training. See you. Bye bye.